All right, so it says, first thing, it says calculate the range, the IQR, and the standard deviation. So I think I already plugged this data into the calculator. So look right, 10.1, 10.2 three times, 10.34 times, 10.4 5 times. 1, 2, 3, 4, 5. 10.5 twice. 10.6 three times. 10.7 once. And then 11. Okay, cool. So once you plug the data in, does everyone understand how to read the data off of a dot plot? Okay, you feel comfortable? And again, you all are going to get very used to doing these lists on the calculator. And again, yes, I have some you can borrow. If you wanted to rent one, you can rent one. I think I have the link to rent one on the thing. I think they only have the 83s left, which is okay. It'll do the same thing. But then once I have my data in, I go back to stat. I go arrow over to one variable stats. I want list 1, and then I'm going to calculate. And so let's see. It says calculate the range. Okay, so the range is the minimum score and the maximum score. So 11 minus 10.1. So that should be 0.9. The IQR is Q3 minus Q1. So it's 10.55 minus 10.3. What does that come to? 25? Oh, hi. Okay, thank you. And then the standard deviation, this will show it as well. So you want to use the SX standard deviation because it's a sample. So your standard deviation is roughly 0.21. I think 2 decimals is fine to round it to, unless it says round it to 3. Don't use the other standard deviation because that's the entire population. Explain the meaning of the range. It's just what's our top score, subtract our bottom score. All of our scores will, be within that region of space. Explain the IQR in context. IQR just means it's Q3 minus Q1. That means that 50% of your data falls in between that IQR, okay? If you go outside of Q3 to the right of Q3, that is 25% of your data. To the left of Q1 is 25% of your data. In between them, so between Q1, Q2 refers to what? Median. So between Q2 or Q1 and Q2, or Q1 and the median is 25%. Between Q2 median and Q3 is also 25%. Okay? Do we feel okay with that? The next couple problems, number 5, calculate the standard deviation in the data sets below. Everything's 4, so what's the standard deviation have to be? 0. Okay? If your data is the exact same, you're not going to deviate from the mean. Okay? And then number 6, heck, you could do it by hand if you're sick and demented. But heck, I would do it this way. Go up here, hit clear, down arrow. I have 1, 2, 3, 5, 100. So I got 1, 2, 3, 5. And that is 100, right? Jeez. So that's going to impact our average. So then once your data is in, stat, one variable stats, so go over to calculate. So we have a mean of 22.2. Okay, so that 100 impacted that very much. And then if I found my standard deviation, our standard deviation is 43.5. So that basically means in order to be one standard deviation to the right or to the left of the mean, you're going to learn something called that will say that within one standard deviation to the left or to the right, you're talking about 68% of your data. So if we have a mean of 22.2, and we have a standard deviation of 43.5. Obviously, if I subtract this from that, I'm going to get to a negative number. Was any of my numbers in there negative? No, that's okay. If I went to the right, if you had 43.5 to 22.1 or 22.2, that's getting to a standard deviation. But what you need to look at with the median as well, the median being 3, the medians are middle of our data. Okay, a 3 falls right in the center of that, but our standard deviation, because of the 100, becomes 22.2. So again, you're just looking at SX for the standard deviation in that place. Without calculating anything, which data appears to have the largest mean and the largest standard deviation? So I would say number 7, data set 2, has the largest mean. And I think their standard deviations would be the same. Why would I say that? On number 7. Yeah, you have 4, 5, 6, 7, 8, and then you have 9, 10, 11, 12, 13. So they're all one digit apart, even though one number's bigger than the other. So you have a bigger average because the numbers are a larger number, but the standard deviation, if we were to find it, would probably be the exact same because they're so close to each other. And that takes me into, I want to show you this. For number 2, I'm going to go into edit. And I'm going to do number 8. So let me clear that. I'm going to show you how the 2 variable stats works. You have 5, 10, 15, 20, 25. And then I'm going to go over to list 2, and then I'm going to put 30, 32, 34, 36, 38, 36, 38, 40. Okay, so if we go under calculate, on this one, stat calculate, we're doing 2 different columns. So I can do 2 variable statistics. We want list 1 and we want list 2. That's fine. Oops, go down. If I calculate that, whoops. No, it shouldn't matter. Calculator's being finicky right now. It should be able to do the 2 variable statistics, even though they are 2 different sets, because it's just finding the mean, the Q1, Q2, Q3. But unfortunately, I don't know why the calculator doesn't want to do this right now. Let's see. Which one do you think has the bigger mean? I would say data set 2 has the larger mean on number 8. And I think the standard deviation is larger on data set 1 because everything seems to be about 5 apart. On data set 2 on number 8, everything is like 2 apart. So you have a larger standard deviation on 8, even though the mean is larger on the other data set. Number 9, we'd have a larger mean. I think the larger mean would have to be data set 2, even though we had 2, 2, 2, and then we had 12, 12, 12. I think that we would have a bigger average using that than going 2, 4, 6, 8, 10, 12. Which one has the larger standard deviation? I definitely think data set 2 has the larger standard deviation because we have a bigger spread than 2 digits per number. Number 10, below are some histograms. Identify the largest and the smallest standard deviation by looking at the histograms. So the one that looks like a nice normal curve, the 5th one down, if you counted 1, 2, 3, 4, 5, the one at the bottom, that is a normal curve. So that's not a big deal on standard deviation. I would say graph 1 and graph 3 have the largest standard deviation because the ends of each one of those has your most data. So it looks like it curves down on graph 1, it curves up on graph 2. And then Be interesting to see what happened with number 4. Graph number 2 has the smallest standard deviation because all of those columns are about the same height. Then let's see. Yeah, the graph number 2 has probably the smallest standard deviation because they're all about the same height. And then you have 2 dot plots below. Compare the two. Well, it seems like the dot plot on top for number 11, our data is much more spread out. Our data below on the bottom one has a closer standard deviation. So the top standard deviation is swayed out further because your data is further out. Your standard deviation on the bottom one is more of a normal curve. It's more clustered together. So something like that. 12. 12, we can plug it into the calculator, find the standard deviation pretty easily. And again, you can always use the calculator on it. I don't care if it says do by hand. Do by hand means I'm using my hands to push the buttons on my calculator. Number 13, if the standard deviation is 0, what does this imply about the observations of the data set? What do you think? They're all the same, yeah. Is it possible for the standard deviation to be a negative value? The answer is no. The reason it's no is because part of the equation when you're finding the standard deviation, you're taking the square root, and we're not talking about numbers that are complex numbers. You're talking about everything that has to be a real number. So if you ever did it by hand and you came up with a standard deviation it's negative, you made an arithmetic error. And then below are means of standard deviations for the weekly sales total for 3 salesmen. And then they want to know who the best salesman is. Ooh. So Ben has an average of 2,200, so he has the higher average, but his standard deviation is 600. So that means basically 68% of his sales would range between 2,800 and 1,400. Jerry has an average of 1,700, but he has a standard deviation 900. So Jerry's range, 68% of his sales. Okay, I have to write these down real quick. So I'm going to write them over on the board. Do it right here. Come on, go back to that. So this is what I'm talking about. Okay, so yeah, Ben. Come on, go to the pen. Ben. Jerry. And Thomas. Okay, how you want to look at this is, we haven't talked about it yet, but basically 68% of Ben's sales would be from 2,800, because I just added these together. I'm also going to subtract them. So what is that, 14, 16? So 68% of his sales will fall between 1,600 and 2,800. If I go to Jerry, if I add and subtract, if I add that, 68% of Jerry's sales would go up to, is that 2,800? Did I do that right? 9. Yep. And then if I subtract 900, I get to 800. And then if we look at this last guy, again, if we add, subtract, they have the same means, but 68% of his sales would go between 2,400 and 1,000. So our best salesman has got to be Ben, but really what our main thing is here, if that number there had dropped significantly lower, let's say a standard deviation was 100, his sales would not be as good. Bless you. So that would mean if this here that I circled in red was 100, that means the 68% of his sales would be between 2,300 and 2,100. But in this case, Ben's our top salesman because, one, yes, he has the highest average, but his spread of his information 68% of it falls in a higher range than the other guys. Most consistent salesman, I think Thomas is probably your most consistent. He might not have the highest average, but I think that's a spread of 1,400, spread of 1,200. I don't know. I think Ben might win that one too. I was just kind of thinking through it. Who is the least consistent? Jerry. Jerry needs some guidance. This is just way too big. Imagine if you make $800 one month, $2,800 another month, $800 the following month. You're not consistent. And between Jerry and Thomas, which salesman is more likely to be given, more likely to have a 2,000 in a given week? This is more likely, I would think, because that goes up to 2,800. But we could talk more about why this would take place on other scenarios. Okay, so we are out of here earlier today because this is our day of 9 o'clock at 8:52. Life is good. Let me just take a look. Can we? I think you have enough information to work on for homework tonight. Worksheet 1-8, which is page 117 and 118. And that should be good for you all. Everyone's happy? I hope.